Let's see. Hi, YouTubers. Hi, Jake Paulers. Hi, Logan Paulers. Hey, Team 10. Hey, guess what I don't like? If you thought I don't like Logan Paul or Jake Paul, you're right. Okay. What a way to maybe get a couple dislikes on my video here. Let's get going with this. You know, just a 4th grade teacher here. Draw a right angle. A right angle. Speaking of Logan Paul or Jake Paul, I'm sure they can do this. Draw a right angle. You could put that little symbol. I drew a pretty good one without a straight edge. Okay. You could have drawn it this way. Okay. It's definitely a right angle. Draw a ray. Could look like this. Could look like that. Could look like that. You don't need to draw 5 of them, just draw one. Draw an obtuse angle, an angle that's larger than 90 degrees. And excuse me. Okay, that looks bigger than a right angle. That also looks bigger than a right angle. I would not, on a test, I would not play around with trying to get too close to 90 degrees because you want to show your teacher you know what an obtuse angle is. Draw an acute angle. Well, that's pretty acute. I can make it even acuter. That's very acute. That's acute as well. Again, don't get too close to 90 degrees because I need to tell at a glance. Yes, it's right. Yes, it's wrong. Very easy for me to check. SpongeBob says that the following image shows 2 parallel line segments. Is SpongeBob right or wrong? Support your answer with mathematical reasoning and or proof. Okay, you can't just say it's right or wrong, but you have to start, everyone should start with the same thing. SpongeBob is, then it depends on what you think. Is he right or is he wrong? He says it shows 2 parallel line segments. Well, let's look. SpongeBob, first off, these aren't line segments, they're rays, so that's going to make it wrong. And then are they even parallel? No. So SpongeBob is wrong. You could say for 2 reasons. How you doing, Mrs. Polkowski?
Doing pretty well.
Speaking of my team, not Team 10, Team Polkowski, we got Elena Jean here. She's being quiet.
The whole team is present.
The whole team is present. SpongeBob is wrong for 2 reasons. First, those are rays, not line segments. Do we want to say second or secondly? Let's just say second. They are not even parallel because they will cross each other. And if I had a straight edge on the test, or even right now, let's see what I can do with pencil, which is a kind of a curved edge. Put it straight right here. Ooh, yeah, I did that good. Okay, so their angle is slightly different. Okay, we can see if we extend this ray that somewhere off the page, very close to the edge of the page, those 2 rays would meet. Ooh, I just realized something. Maybe you'd say they won't meet. It still doesn't make them parallel. This is a ray, so it actually doesn't extend this way. It still doesn't make these parallel with each other. Okay, so SpongeBob is wrong for 2 reasons. First, those are rays, not line segments. Second, they are not even parallel because they will cross each other. Okay, sounds good to me. Draw a line segment that is perpendicular to the ray below. And I like this because you got to know 3 things. You got to know what a line segment is. You got to know what perpendicular means, and you got to find the ray below. Which one is the ray? This is a line segment, ray. So here's my ray, and I need to make a line segment that is perpendicular to this ray. So you could draw it this way. There's a line segment. You could draw it like that. You could put those on the end just to show the endpoints. That's still a line segment. If you cross it like here, that is a line segment. If you cross it here, that is a line segment. So anything that is perpendicular, making a right angle, a 90-degree angle, will work. It's very easy for me to check as well. Okay. Then this one should say draw a line that is parallel to the line segment below. Again, where's the line segment? Line, ray, line segment. And I need to draw a line that is parallel to the line segment. So here is the line segment. And let me try to make freehand a parallel line. Pretty decent. If you need to use a ruler, I suppose you could. You just want to make sure it doesn't look like it would ever cross this. And they run alongside one another. You could have drawn it down here. It doesn't have to matter whether it's long or short, but it should be matching the same angle. Any of these would work. Draw a pair of perpendicular lines. Will they use that in art, Mrs. Polkowski?
If we get to perspective, they would.
Okay, and this is where one of the students was saying something about 1 point perspective as far as parallel lines.
Yeah, you really have to understand parallel and perpendicular lines to draw perspective correctly.
Okay, but that says perpendicular, so I drew perpendicular. I could always put one of those in if it looks like my work was sloppy and that's telling me it's a 90-degree angle. You only need one of those pairs. Draw a point. Easiest point on the test. Pun intended. Okay? What do you say? What's this girl saying? Let's pan over here. Show us parallel. Use your hands. No? Huh. Yeah. Yeah. Say 4th grade is cool. Maybe that's too much struggle for her. And she's not going to make any progress.
It's outside of CPD.
It was outside of her ZPD, kind of like in your AR level. Okay, you have a ZPD. Let's see, determine whether the following image contains parallel, perpendicular, or neither parallel nor perpendicular lines. Write your answer on the line provided. Here's the line provided. Let's see, are these crossing each other? Yes, fine. They're intersecting lines. They're not parallel. If they were parallel, they would never cross each other. Parallel pencils, intersecting pencils, they're still not parallel or perpendicular. Perpendicular pencils. Okay, so it's definitely not parallel, and these are not 90-degree angles. In fact, this is an obtuse angle, and here's an acute angle. So it's neither parallel nor perpendicular. Hey, we've learned to say it out loud. You should probably also be able to spell it. It's written up here as well. So here's that obtuse angle, and if it really were parallel, this one would look more like, we'd have something that would look like that. That would be what parallel a line would look like to that one. And if it were actually perpendicular, let's pick this line. This one would actually come up more like, I'll go ahead and draw it. Now I have a perpendicular line to this one. Okay. It's me trying to make an arrow. Okay. Determine whether the following image contains parallel, perpendicular, or neither parallel nor perpendicular lines. Same question, different image. Write your answer on the line provided. Okay? Well, technically these are not lines, they're rays, but let's just assume that they should be correct. They're not perpendicular, so are they parallel? Well, if this ray were actually parallel to this one, it would look more like that, wouldn't it? Because this one's going straight horizontally across the paper. So the answer is it's not parallel and it's not perpendicular. So neither parallel nor perpendicular. Last two questions. Identify two or more geometric concepts in the following image. Be sure to use arrows to point out the features. Okay, so here's an interesting image. It's based on Piet Mondrian. I didn't create it. Someone threw SpongeBob into this. Incidentally, when I was in 7th grade or 8th grade, I did art, and I might have tried to copy a Mondrian for an assignment. Two or more geometric features. Well, I see 3 of them, and then I think there's actually 4. So let's look at the ones I can definitely see. Maybe you can see them too. Oh, can I zoom in? Yeah. Okay, there's that image. So here's what I see. I see perpendicular lines. I'm glad you came back, Mrs. Polkowski. Because... No, but that's what I'm concerned about. I see perpendicular lines crossing each other, creating right angles. So that's 2 geometric concepts that most of us learned about so far. Creating right angles. I'm going to underline those just to make sure the teacher sees that I understand that. So I'm going to draw a line. Here's a perpendicular line. There's the other one. And here's the right angle. Okay, so actually right now let's just check what the question was asking. Identify 2 or more. There's 1, there's 2 geometric concepts in the following image. So I know I'm done. But because there's actually a lot of different ways you can answer this question, I'm going to go through ahead and find all the different features. Okay, so I also see parallel lines. So this line here going horizontal is parallel to that line, and this line going horizontal. Let me go ahead and draw an arrow. There are also parallel lines. Lastly, hey, if you look closely right here, there's a lot of right angles on this in this image. But what I see right here is an acute angle. Draw your arrow. So there's a bunch of arrows. Does it make sense to me? Yeah. Okay. And wrapping up. Power's kind of getting low on my phone. So let me do my best here. What makes right angles, acute angles, and obtuse angles different from one another? You may draw a picture if it helps, but please make sure to explain in words as well. What makes right angles, acute angles, and obtuse angles different from one another? Okay? Right angles always have 90 degrees. That little symbol means degrees. Acute angles, though. Oh, what's going on there? Acute angles, though, only always have less than 90 degrees. So is that something that makes them different? Yes. You know what, I'm going to just cross that out. I'm going to write the word degrees, just so you can see. You can use a symbol, or you can just write the words. Then, obtuse angles always have more than 90 degrees. Okay, and I can draw a picture just to make sure the teacher knows, hey, right angle, 90 degrees. Acute angle, less than 90 degrees. And in fact, the less than symbol is an acute angle itself. And then obtuse. But here's the thing, I really want to see the words. I don't want to see this is the explanation. This is too brief, and it's not using enough reasoning powers. Obtuse angles have more than 90 degrees, and show your obtuse. All right, I think we've drawn points, lines, line segments, rays, angles, all three kinds, and perpendicular and parallel lines. And we've identified them in two-dimensional figures, I believe. If you've mastered this, you have mastered those geometric concepts for 4th grade.